Thanks for having me today. I've actually learned a lot when I've been kind of preparing for this thing. I just want to start off by saying, kind of a jack of all trades, but I'm not a specialist in really much of anything. So that's kind of how I try to live my life. But we're going to start off talking a little bit about some geology stuff. So hopefully that won't bore you too much. But I think it's really important. That's kind of what I've come to the conclusion in the job that I do, where I do a lot of restoration work, is, these are really good explanatory values to see why plants are where they are. So we'll get into it. So Houston's got really dynamic geology, even though it's very, very young. For the most part, it's been shaped by water. So either that's from riverine systems, so fluvial, or by marine systems, which is deltic. So for the most part, it's about 1 million years old or younger. So in terms of Earth time, and that's the hard thing to think about. We think of 100 years is a long time, but for the Earth, that's a blip of time. So, but yeah, most of these things arise from sediments from north of us. So as time happens and water comes down and wind comes down, it takes the old layer of the Earth off and sends it downstream. And that's how most of the soils that we have here got here. And it has a lot of really interesting shifts on local flora. I kind of look at it like this, and it takes a little while to get to the point where you can see these changes because they're not as apparent as, say, the mountains. If you go to the mountains, over a couple hundred feet, you'll see some pretty dramatic shifts in vegetation. But here, when you get to the point where you can kind of be like, oh, that's that and that and that and that, and you can see changes of the vegetation in the matter of inches. So it's just really interesting, in terms of scale, the mountains have this monster scale, which makes sense, right? They're grandiose. But here, we might have 3 foot of topographic relief on a prairie, but you can still see these floral shifts across the site. So it's quite interesting. So this graph really does a good job of kind of explaining kind of the local, how things shaped and how they became what they were. So we started about 100,000 years ago, and if you look at the sea level, it was almost 200 foot higher than what it is right now. So we would have been underwater right now. And you progress this time, and this was when the Lissy Formation, which we'll talk a little bit more about, was mostly deposited. And then you get this little blip right here, and then you enter into the Glacial Age. And so the Glacial Age, basically, the sea levels drop dramatically, and that's when all the water in the world was, for the most, not all of it, but a lot of it was, up on the poles in the form of glaciers. And then you get this dramatic rebound about 20,000 years ago. And there's some debate as to how that happened, but that's an interesting topic to look into. And that's when, at this point, is when most of the megafauna that used to live here, we had lions, and we had horses, and we had rhinoceros, and a lot of those things died at that time. So it's an interesting event that whatever happened there, it was a game changer in terms of the environment here. And this slide kind of talks about that. So, here's the glacier. It crept down into the Midwest. That's why, when you're in the Midwest, that's why it's all soybeans and corn, because it was glacial till soils. And so they're really deep soils, and they're real flat, but you can see the rocks of the glaciers when they crept across the earth. And then you kind of see, come down a little bit now, what the plains is, it was spruce and pine forest. And then when you get down here, the habitat they think was way more similar to what you would expect now when you get north of here by several hundred miles, where it's those big broadleaf forests. It wasn't prairie here. I think it was mostly forested areas. And you can see here, so here's the dashed line is the current coastline. And you can see how far out the water was at that point. And so here's an example of Florida. There's the peninsula as you know it now, but you can see it's several hundred miles further than what it was, except for right down here in Miami where it gets deep real fast. So a little bit about the 2 soil types that the community I'm going to talk about grows on. The first is the Lissy Formation. It's a little bit older formation. For the most part, it was laid down by floodplains, and then it was also impacted by the sea level at that point was higher, and so it allowed for some of the marine deposition to occur as well. So it's more deltic by nature. And because it's a little bit older, generally the older an area is, the more dissected it is. And so this is a little bit older than the Beaumont Formation, so there's slightly more of an undulation to a slight rolling, but it's still not very distinctive. And most of the soils here are quite a bit brighter than the Beaumont Formation soils are. They're typically like kind of a brownish or a pale beige color. And for the most part, the top 18 inches to 3 feet are sandy loam, but then underneath that is generally underlain by clay. And we'll talk about why that matters in a little bit. And then the Beaumont is a really new formation. Yeah, it's fine, whatever. So it's less than 60,000 years old. For the most part, what happened was when those sea levels were way out from what they were, creeks naturally have sandy, basically natural levees. And at that point, since the water was quite a bit further out, because the creeks that were here now were trying to drop elevation to get to the water was way further out. And because of that, when you had pulsed events, flooding events, when that happens, the floodwaters pick up a bunch of fine sediments, so clays and silts. And for the most part, those become colloidal. And they don't settle out until there's no more velocity left in the water. They have to be still for those really, really tiny sediments to settle out. And so I think that a lot of times with the Beaumont Formation, what happened was you had these big natural levees, floods would happen, and they would take and basically coat the Beaumont Formation with these really fine sediments, which makes sense. I mean, that's the gumbo clay. That's the stuff have fun walking in that when it's wet. It just sticks to your feet, and it's super heavy. But because of that, I mean, it's a really interesting soil. There's hardly any percolation. And then like right now that we're actually kind of coming out and having a dry period, it also has this fracture kind of thing, what's called a gilgai, where you get these soil cracks because clays are really shrink swell. So when it's wet, it expands. And then when it dries out, it forms cracks. And that's also why a lot of times these prairies became rice fields, because of that, when they had dried out and had cracks, then you had different kind of nutrients falling there and dead plant parts, so it made them fairly rich soils. And they're very, very dark. They're normally either a dark brown to a black, and they're also very flat. So here's kind of just the basic geological map. So for the most part, we'll be talking about, this is the Beaumont Formation, kind of this light orangey beige color, and then the kind of the northwestern part of the county is Lissy, and here's Katy Prairie, and yeah, you can see it forms this concentric bands, it corresponds a lot with sea level rise and fall. So kind of the next really big abiotic factor to think about, so we kind of have the soils covered now and kind of have a little bit of understanding maybe how they got there. The next thing that really influences our plants here is hydrology, which basically means how much water sits on a landscape. And here, as we're about to see now, we might be entering into a dry period, which kind of would be a nice relief because of the last couple of years. But it's really cyclical here. We have these really, really wet periods and we have these really, really drying out periods. And that plays a lot of impact. I mean, I think about from a plant's perspective, like, man, they have to deal with, if you go from a severe drought like in 2011 to like a Harvey event, I mean, and these things can survive that, it's quite, I mean, to me, it's quite impressive. And then, so yeah, now that we're entering into like a dry period, then that's another driver that kind of really made this area prairie, was because you get these droughts, then you have some lightning happen, dried out plant conditions, bam, there's a fire. And for the most part, these prairies were, let's see what they call that. Well, I think we'll talk about that in a second. So, and the thing that's also cool about this area is especially the Lissy Formation, since it's a little bit older and has some more dissection, as water basically travels across the landscape, it's, say it's channelized in a stream. If you get a big enough rain event, if it detects there's like a lower, like in the floodwaters will detect like there's like a lower elevation over there, and then it'll oftentimes cut and go that way and form a new channel. And so you'll get these abandoned meanders across the landscape. But because a lot of the creeks that spread across the prairie weren't big rivers where you have these, large oxbows like you'd expect along, like the Brazos River or the Colorado River. Those are really noticeable oxbows, but on this landscape, and the next photo will show that, it's a really prominent feature on the native prairies here. And the biggest thing with the hydrology is what it did is because there was so much slight undulation on landscape and kind of this micro change in soils from finer sediments to sandier sediments, the finer sediments in the lower spots stayed wetter, but then that fed the hydrology into the sandier areas. And there's a really good illustration I'll show you in a second. So just kind of here, this is from the 40s when there wasn't much out here. There's a little bit of rice up here, but so here's a creek, and it's probably an intermittent creek, which means it flows some of the year, but not most of the year. Barely any trees. I think there's just a slight few up here. But here's kind of one of those old abandoned channels. It's not receiving active flow. You don't see an actual bank on it, but I mean, obviously, you look at it, it's had to be a creek at some point. And then the other big thing is everyone talks about these prairie potholes or depressions. They're not true potholes like the ones up in the Dakotas and on the Missouri Coteau. But then, you kind of have like these other depressional areas that are they kind of started filling in. As floodwaters came across, they picked up some more sediment and they kind of laid them out there. And so they're not quite as deep. And so it's a very varied topography in a matter of just a feet or two of elevation. So it's real interesting. So here's the one, I really like this one. So this would be from the Lissy Formation. So underneath all of this is a clay layer. And then basically anything that sits on top of it is an occluded aquifer, or basically like a perched water table. So for the most part, once this fills up with water, it does not percolate down to the actual water table here, just because that clay layer is so thick that the infiltration rate's like next to nothing. I mean, maybe right along the mounds they could get down, but for the most part, it was really tough. But so you have these mounds, and then you have these depressions. And this is really important about the talk tonight about how these saline barrens develop, was that you can see, so there's more precipitation in this model than there is evaporation or transpiration. So basically plants uptaking water and putting it back in the atmosphere. So right now, the mounds and the intermoundal areas are feeding the depressions and filling it up. And if it filled up, then at that point it basically backed up and you actually got standing water on top of the intermounds. If you look at the next model, so it's basically the reverse. Now there's more evapotranspiration than there is rain or precipitation. So the depressions into these sandier soils feed the water back up. And so there's a lot of hydrostatic pressure going on here. And I think that's where, and we'll talk about it for a second here. I think, so basically, I think what's happening why these barrens are there is because it's picking up soluble salts, and because of this interplay back and forth between a high spot and a low spot, it's putting a lot of salts right here in this intermoundal area. And that to me seems like the most valid hypothesis I don't know how you would test that, but they've done some work on these areas and they're definitely pretty saline, but that seems like that would be the driver that would explain why these barrens are there. So we're going to talk just a little bit about kind of broad vegetation real fast, and then we're going to get right into these barrens. So as probably most of y'all know, from a macro scale, most of our prairies are dominated by warm season grasses, sedges, sunflowers, asters, to a lesser extent the Lamiaceae family, the mint family, and then also the legumes from a very high level. And then, coming down to a finer scale, like I talked about earlier, they're really influenced by water. So how capable are they handling anaerobic conditions? And anaerobic conditions are hard to handle because you don't have oxygen in the soil, and then oftentimes that affects nutrient availability. So there's a certain suite of plants that can handle those conditions, and then a lot of them can't, or to what degree they can and how long. So that really shapes where you see plants in this area. So now we're going to get into the barrens themselves. So I really like the barrens just because most of our endemics, which means plants that are only found in a small area here, pretty much come from the barrens. The other area that has a lot of endemics in the Texas coast is down in the sand sheet and around Corpus Christi area. It seems like there's a decent amount down there as well. So like I talked about in that previous slide, these are formed, I think, because of this hydrostatic pressure that's picking up these free, sodium molecules and transporting them back and forth and pretty much depositing them right there at the base of most of these mounds or on those intermoundal areas, those flats. And that's the best I got. So, but generally speaking, the soils are fairly sandy there, sandy loams. Oftentimes it seems like from the couple soil pits I've actually dug down to see, a lot of times the actual sands there are a little bit more shallow and you hit the clay layer faster, that's a pretty interesting feature. And then growing conditions. So because I think of how easy it is to hit that clay layer, when it's a wetter year, these areas stay pretty wet. They stay saturated, so they probably have some level of anaerobic biology kind of going on there. And then as it gets warmer, because these are shallow soils, if you don't get more precipitation, they dry out really rapidly. And then once you hit summertime, it's kind of almost like a desert out there. So they go from really wet to really dry. And because there's not many plants that can grow on there, they get a lot of radiative pressure. So I kind of want to give an example, just if y'all, for some reason, find these things interesting, and you should ever want to go try to find them yourselves, especially new ones, because there's some big conservation issues here. I'll try to walk you through that. So we're going to use the Warren Ranch example. They probably have some of the best ones that are actually protected by conservation easement right now. So here you go. To me, it's a pretty dramatic photo because I know I'm looking at, but all these bright spots, those are the barrens, and they stick out especially in a drier year, they stick out like a sore thumb because the sand's exposed and that sand just reflects that super bright light back to the lens, and it's very noticeable. But you can see, I think I zoom in a little bit more. So a lot of times you can see around, so here's a mima mound, so a higher spot, and look at the base. So all the way around the base, you have this bright sand just shining back at you. And you can find it where, they're more kind of in the flats and it's more spread out, but right around the edge of the base is a really common feature, and you can see them all over the landscape. So going forward in 78, still can see quite a few. Looks like it's a wetter year that year, or at least when this photo was taken, because there's not quite as apparent. But you can see rice. This is all rice right here, rice. Maybe, I don't know, the salt mine, yeah, right there. So, you kind of start seeing it's not as dramatic. It wasn't the whole, they're starting to get creep of agriculture in the area. But you can still see a couple of the features in here, but they're not as readily visible. And then going forward, so in modernity, you can kind of see this is a really wet year, and you can see that all the potholes are filled up, and then kind of the interstitial areas between the potholes look kind of dark. And generally, when you look at the aerials and you see that darker color, that means the ground is at least saturated for the most part. That's just a good way to kind of interpret these photos. So you can kind of see, you can see a few of these features, but they're just not. I mean, it takes kind of a trained eye at this point to really kind of pick them out. At least in my mind, it does. And so flash forward to the drought. I mean, even from this level, you can start seeing how bright those features are. And then you zoom in a little bit and they're plain as day. So if you ever did want to go look for these things in Google Earth, what I tend to do normally is I'll go back to the 1944 aerial imagery and just look for basically, was it a prairie for sure, and were these features present then? And typically they are, and they're really easy to see. And then when you start going through time, a lot of times what will happen is, you'll get some woody species that grow up around them, and becomes forest or shrub. But because these conditions are so hard to grow on, for the most part, most woody plants can't grow on them. So a lot of times you'll see areas that are open, they'll be small, maybe 1/10 of an acre, but then you'll have woods all the way around them. But they just found, so one of the plants we'll talk about is Texas prairie dawn, but they just found a population that was just like that. It was all like scrubby tallow, and it was kind of like a junk site, but I don't know how they found it, but they did a 22-acre restoration, and I mean, I think I've recorded like 175 plants out there, prairie plants. Just the seed bank was there. They came in, the hydroaxed all the tallow, and so they're a really good indicator that if you can see these remnant saline barrens, it's also a really good indicator there's probably a great prairie underneath it. So in terms of conservation, just prairie-wide. I think Houston area's Hymenoxys prairies are here, potentially, are underneath woods right now. So just something to think about. So they're actually a good indicator for just prairies, period. All right, so yeah, these are totally driven by saline conditions. It's like, well, Stephen Benigno, he's also an expert on Texas Prairie Dawn, that guy right there in the Houston shirt. But he's done some soil tests, and I mean, these areas have roughly 70% more saline concentration than the surrounding areas. So it's quite a bit higher. It makes sense why we're seeing this dramatic shift in vegetation than what you do in the areas immediately adjacent. So like I already said, kind of water makes a big difference, and it makes a big difference on these because what seems to happen is in really, really wet years in winters and springs, it seems like there's some level of dissolving of these sodiums to where these barrens get way more populated by annual species than they typically are. So it seemed like the last couple years from when they've been so wet, there's been a lot of like dwarf dandelion and some of the other species that might be there just in a lot lower numbers. They just really blow up, and a lot of these species are really small, and even though the other plants are small, they provide a lot of competitive stress for them. So it seems like the droughty conditions help basically clear these barrens of all these, let's call them unwanted weeds. They're really not. I mean, they're living their life too. But it seems like these drought conditions really help clear these things out and provide quality habitat for the species we're about to talk about. So we're going to start off at the edge of the barren. So we've come off the prairie, and then you can see the barren there, and about to show you a picture, but there's a typical suite of plants that grow on the edge of this. And the biggest one is called Gulf Coast Spartina. I don't know if y'all run into it. If you have, it's probably memorable. It's quite pointy, so it will definitely make you bleed. And it's a neat one though. It's real common down on the coast, and especially in like cattle pastures. Cows don't eat it very much, so I'm sure y'all have probably seen it. It's real super bunchy grass. Another one that's there generally on the edge, can be in the prairie, but it's not as common, is Texas endemic. It's Texas windmill grass. We'll talk about that a little bit later on. And then some of the other ones are sharp blazing star, Gulf muley. So some of these are just prairie species in general, but they also do pretty well on the edge. This was a good one, East Texas green thread, Lindenheimer's bee blossom, Texas snakeweed, and then prickly pear species. There's a couple that will hang out on the edge here. So so now we're getting into the barren, so you can actually see some pictures. There'll be a lot more pictures from here out, so enjoy that. But you can see the line. So like, you can see here's this bright sandy soil. There's pretty good population of plants in here. This is mostly, Sporobolus pyramidatus. And then this is actually a Texas endemic right here. It's dead right now, but that's 3-flower broom weed. But then you kind of come off, and then all of a sudden you hit a big line of, this is all tall vegetation. But it definitely, you can see that exclusionary line where these soils just are basically preventing that plant from growing there. So it's these things, you're underground with them, they're 100% noticeable. There's no tall vegetation on them at all. So Jason Singhurst, I'm sure some of you at least know who he is. They did a paper out at Warren Ranch, and they kind of were speculating that there's kind of 2 phases to this plant community. Not quite apparent what it is. I think the first one seems like it doesn't have as many perennial species in it, and some of the endemic species are not as prevalent in this phase of the community. So world drop seed is one of the species that's out there. It's a little grass that it's actually pretty common in medians too. It can just handle like just trash conditions. So a cool one, we'll see a picture of it in a minute, is bristle seed sandspurry. There's one called narrowleaf marsh elder. And then the cool one on this one is actually a cyanobacteria, which is called nostoc. I don't know if y'all have ever seen it. It looks like someone had a dirty nose with like a bunch of runny stuff and then blew it on the ground. It's like this dark, like snotty looking stuff. But nostoc has some really, so Nostoc is cool because most of my favorite habitats are like these, either this type stuff or glades where it's just like basically like the nastiest, least formed soils in the world. This is where you get really weird plants that grow. And Nostoc is like, it's always there. I mean, it has so many qualities that are really interesting. It can fix nitrogen, so basically take atmospheric nitrogen and incorporate it into his body. It can desiccate, so when it dries up, it just looks like a black crust. And so it's got to be wet to be in that jelly, snotty state. And then once that happens, once it dries up, it looks like just like a black, crusty thing. And so I think that's kind of, it's an interesting species. I think that it provides the ability to maybe add some increased nutrients into these sites. So here's some pictures. I mean, these are all like, so almost all these plants are just a couple, like an inch or two tall. I mean, for the most part, they're just tiny. And it's, so when you go look for them, like you pretty much have to get in your hands and knees to see a lot of the diversity because they're so small. And then there's a couple of them, I don't think I have a picture, but there's a couple, there's one called crassula that's like about that tall. But when it gets later and when it gets spent, it turns red, and it forms pretty dense colonies. So you just see like a red painting kind of on the ground, and that's how you find it. But yeah, so it's kind of one of those things that, like, I don't know, you have to appreciate minutia to enjoy these communities. But if you can do so, they're quite interesting and they're pretty captivating. But yeah, definitely, you have to be kind of weird. So I like this one. There's little flowers right here. So this one's called lesser swine cress, and this one can actually get really big, and it can be a weed kind of in like gardens and whatnot. But I mean, I've seen it, in nice soil where it gets like yay big. It won't get very tall, but out on these barrens, it's only about yay big. It normally has a couple leaves, and then it has one flowering set that comes off of it. It does not get big, so it's interesting to see the plants that can grow on these sites, but then can also be competitive enough, or at least be released from pressure on other areas where they have richer soils, and see how much bigger they can get on these other properties or these other soil conditions. So, and here's a nostoc. Unfortunately, I don't have a good picture of it when it's wet and looks gross, but it kind of still looks gross a little bit here. But it's all this black, crusty stuff in there. It looks almost more like a fungi. And then here's a good showstopper. I mean, this is a tiny plant too, but it does have really, really large flowers. It's, what's it called? Yellow hedge hyssop, Gradiola flava. And it was blooming like crazy this year. It's beautiful when you get thousands at one time, and you can kind of like look down and just see like just yellow. But again, yay big. Maybe so a champion plant of almost all these is like 3 or 4 inches tall. And when you see one like that, you're like, oh my God, it's so big. And then you're like, oh, it's still a tiny plant. So, but so then we kind of transition into this, maybe it's a climax community. I don't know. I meant to ask Jason about it and see what he thought about it. But you do start seeing a more prevalence of these perennial plants. And then like the Texas prairie dawn. So, I mean, the main one that's the showstopper here in terms of it's a federally listed plant species is Texas prairie dawn. And it's, again, a very unassuming plant, but it is pretty neat. And then, so a lot of these are Texas natives and only from Texas. Thorovia triflora, Texas, or 3-flower broomweed. Texas wilcomi is another native, only to Texas. And then the Texas saltbush, I think, is only native here. It might extend into New Mexico, but these are all plants that are just found locally and really nowhere else. So here's kind of a neat picture. This is Texas prairie dawn. It basically sits in it's got these little rosettes, and that's how it sits. It starts germinating, I think, in December, and then come about March, it'll send up these little flowers. It looks like it's just like a discoidal head, but it actually has like really, really tiny ray flowers. And then the other thing that's pretty common on these sites is the plantains. there's several species of plantains that are quite common on this site. So, but they're all very diminutive. But there's one called Plantago pusilla that's like super cute. It's like got just tiny leaves, and I don't know if you guys appreciate small stuff. So here's a better picture of the 3-flower broom weed, and it's really easy to spot on the barrens, even though it's like just starting to germinate right now, or I guess come off it's perennial. Come back off the roots, but it's pretty sprawling plant. And so in springtime, when you're out looking at most of the spring bloomers, you can still see these big colonies of it. And so here's it in flower, and thanks Jason gave me this photo because I didn't have a good photo of it in flower. So it's not, I mean, most of these plants, I mean, they're not showstoppers. They're not like blazing stars or some of like the, more impressive prairie plants, or, like a big magnolia in bloom. But, if you get close enough to them, they really do have some pretty intricate structures on them, and I think they're quite neat. So here's some Texas saltbush about coming out. So it can get really quite large. It's a sprawler, but it's kind of got these, so in summertime, most of the plants that are perennial that hang out on these places are very much kind of more in that succulent style plant. They have, big, thick, waxy cuticles. They don't have a lot of stomata. They're basically trying to conserve that water because of how droughty it is during summertime. And then this is the other cool thing about these barrens that's not plant related, but they seem to be like really, really important for our native bees. Because they have so much exposed soil, I mean, the diversity of bees on these sites is, I don't know if anyone's ever done research on them, but it seems to be like there's at least probably 10 or 15 species. And then when the sun comes up enough that they're heated up to where they actually start being active, it's just like a constant loud buzz out there. So, I mean, in terms of like, we'll get to conservation a little bit, but in terms of like conservation in these areas, like what does this do for our native pollinators? And it's obviously a concern for us. So I think that's one of the areas they actually utilize a lot for nesting. And so here's a couple more flowers that are out there. Woolly cottonflower, it's in the amaranth family. Smooth scorpion weed, it's quite nice. I've always liked this one. It's called a pinweed. It's a real small one, but it's got some interesting flowering structures on it. But it's not very showy. But it's pretty much found here, and then it's kind of found in like Central Texas. And then this is one that I haven't seen actually this is one that Jason found out there. I haven't seen it out here. I've only seen it up in some of the glades in East Texas, but it's Texas Sunnyvale, and it's a pretty rare plant. It's only found from a couple areas. So flame flower, it's one that it's hard to get it in flower. It only blooms for a couple hours in the afternoon, and it's in that like purslane family. So it's a pretty small, it has like a really small like roseate kind of leaves that are really, really like cactus-like. And then pygmy cudweed, it's also another really tiny plant, but it's got these really hairy flowering structures. Silver dwarf morning glory, that one is a little bit more common. I feel like I can find it sometimes on just more of a prairie than an actual barren, but it's pretty common on the barrens as well. And then I hope most of you have seen the bracteative fan petals, but it's pretty common in disturbance areas along areas that are really, really mowed a lot. You can find it on there as well, so it's not the most uncommon plant. So we'll talk a little bit about these plants. So the Texas prairie dawn is probably the rarest plant on these barrens. Well, that or Ray Jacksonia. But it's only known from about 50 sites. But the interesting thing about it is they thought when they first found it, it was in like the 1800s, and then they thought it was like lost to science, and they rediscovered it in I think in the 1980s, and it was only from Harris County and Fort Bend County. Well, now they're starting to find these kind of disjunct populations north of here in East Texas, and then kind of the post-oak savanna. So maybe there's hope that there's actually more of this stuff out there than what we originally thought. My one buddy found a new population of it 2 years ago, and he said it's like a very extensive population. So maybe there's hope for the species that it's way more widespread than we thought it was just no one goes looking for 1-inch tall plants. So, I mean, that's a pretty good hypothesis on that one too. So hopefully that's, hopefully that is true. I mean, maybe as our saline barrens go away because of development, that, it'll be okay up north. So like I was saying, a lot of these barren plants, they're not great competitors. They develop for these very unique conditions that basically just excluded their competition. So in wetter years, they do struggle some to, basically compete against these other annuals that are a little bit more aggressive. And like I was saying, so basically the plants vary from year to year. Generally following a really dry year where it pushes all the other stuff out, these plants do great. In a wetter year, they don't do quite as well. And the interesting thing about this, and we'll talk about this in a couple other ones, is it's only found on these inland sites, which is, so I mean, they're kind of salty. I mean, they're salty. That's what gives them basically nothing else grows there. But they're not found on the coast, because you get to the coast and like oftentimes once you get to the upper part of the marsh, you have those big crusty salt flats, and some of the species we'll talk about can grow there. But for whatever reason, this one, I don't know if it's just too salty for it or what the deal is, but just interesting when you start looking at the distribution of these plants, like why is it not there in other ones, or some of the other ones are. So Texas windmill grass, I know grasses are kind of boring, but I like them. So, but again, this one's interesting because it's got this really scattered distribution. I mean, there's a record of it all the way out in like the Pecos. And then there's like a central Texas record, but for the most part, most records around here, most of them are around these saline barrens. But it's just interesting to see like, well, how is it all the way out there? It's just, those are fascinating mysteries that I don't know if anyone will ever solve it. But it generally grows kind of on that edge. It's not a very competitive grass. It kind of has a small, like little basal roseate. Those leaves don't get very tall. The impressive thing about it when you actually see it is, it's got these really, really long seed heads on it. So it's pretty cool when you can see it, but it's not the most showy thing in the world. Definitely the most showy plant that's on the barren, that's endemic to this area, and this is one that's only found in 2 counties. I think it's only found in Harris County and Fort Bend County. There might be a Galveston record, or no, Galveston, my bad. So Harris and Galveston, it's called Houston Camphor Daisy. This one actually is quite showy. It blooms generally in the fall time, and it's a multi-stem plant, it's a perennial, and it's actually has like a real flower on it. So surprise, good for you, you get to see one that actually has a real flower. And then it's kind of got this camphor smell. It's like this real pungent smell, and it's just an anti-herbivory mechanism. And then this one is the 3-flower broomweed, and this is the one that's kind of interesting. This one occurs along the coast, on the coastal saline barrens. So it's just interesting that like this one was able to somehow occupy that area, but the rest of them weren't. It's just curious. I mean, in terms of conservation, maybe there is a way to introduce some of these other species down where this one lives, and because a lot of those areas are under state protection, and they keep the species persisting on. So finally, we'll talk about conservation just a little bit. So, historically, we don't know how common these were. I mean, based on that one photo I showed you from Warren Ranch, it looked like these areas were quite common at one point. As man's pushed out into the prairie, especially agriculture, once an area, especially has been riced, rice farming takes the high spots and pushes them into the low spots. And when you have that, all that hundreds of, 20s and 30s, thousands of years, all that effort of water and wind just goes bye-bye. And I don't think these things, you can create them. So basically what's left is what's left. And I don't know if we want to save them or not, but it's one of those habitats. I think once it's gone, once it's plowed over, that's it. You can't recreate them, I don't think. So in terms of ecological importance, I don't know, like I was telling you, they're all tiny. So we got to think about, do we care about other, species that inhabit the world as we, with us, or not? It's kind of a philosophical question to a point. But, like I was saying, I think in terms of what could actually impact humans is all those bees that nest on these habitats are out there. They provide a really good pollination service. And so, like I was saying, biggest threat is conversion. And the other thing is, I think, lack of connectivity. When you saw that photo from the 40s, those things were everywhere, and now it's just there's a couple properties here and there that have them. Well, there's not all the other ones mixed in there now. So I mean, do they even get seed from site to site? And so what does that do for the small populations? And maybe that really impacts them. So I mean, the one positive thing is on a couple of the road medians, I have seen some of these slicks maybe develop. So maybe there is a way to look at providing habitat somewhere else. And then generally the general lack of knowledge about where these things might occur in other places of Texas. So going forward, I mean, if y'all are interested, I mean, I would strongly suggest try to identify more of these, protect more of these, maintain them. The cool thing is cows don't eat hardly anything on these sites, so totally, grazing in these sites are 100% in line with each other. And then lastly, the Mercer Arboretum has been doing genetic collection or seed collection to basically preserve the genetic lineage of several of these species. So at least if they keep disappearing, we find a way to recreate this habitat, we could re-inoculate those sites with seeds that are frozen up at the Mercer with Anita Tiller.